So far, we've explored concepts called identities. Now, remember what an identity was? Let's do an example, and we'll use that example to kind of help refresh our memory. So, one of the identities that's very popular that we see happen all the time uh, was sine squared plus cosine squared. That equals 1. Now, what makes an identity different from an equation? An identity, this is true for all values, or whatever we put in there. That's what made an identity an identity. However, equations, for example, maybe like the sine of x equals 1/2, well, that's only true at certain values of x, not all values of x. So what we want to explore right now is this idea called trigonometric equations. How do we determine the solutions to some equations? Now, sine of x equals 1/2. Notice that I have the sine curve drawn, well, as best as I could. So imagine with me, I have the sine curve. This pink line represents x or the value 1/2. Now, what do you notice about my solutions to this particular equation? Yeah, there's a lot of them. Notice that right here, my sine curve crosses the value 1/2, crosses again the value 1/2, crosses again with the value 1/2, and so forth. And then if my window is large enough, I could scan a whole or create a whole bunch of values. So we can say that there's pretty much infinitely many values. So what should we do? How do we kind of start to wrestle with this type of an idea, and how do we communicate to others what solutions are? Well, in this particular one, sine x equals 1/2, I see that I have solutions here at pi sixth and 5 pi sixth. Have some other solutions I'm going to get to in a few moments. So how we do this is, first of all, let's understand what the typical period is of the sine curve. Do you remember the typical period of the sine curve is? It goes from 0 to 2 pi. So within that period, I want to find out how many times is this equation true. Sine of x is positive 1/2, so I know that happens with a value up here. I'm not going to look for values in the lower section there. So I've identified my total solutions within this particular period are at pi sixth and 5 pi sixth. From there, we know that the period repeats itself every 2 pi, so I'm going to take one solution, which is pi sixth, and I'm just going to keep adding 2 pi's to it. So pi sixth plus 2 pi, well, if I get common denominators, that becomes pi sixth plus 12 6 pi, and that equals 13 6 pi. And so that validates this other solution that I have. And likewise with 5 pi sixth, add 2 pi to that, and you can see that I get 17 pi sixth. So what do we do then? Do I just keep adding 2 pi's to it as we continue along the way? Rather, what we're going to do is we're going to add and I think we use ends typically for this one, is that we're going to take our solutions, which in this case is pi sixth plus 2 n pi. And then the other solution that fell within that original period, which was 5 pi sixth. And likewise, we're going to add 2 n pi to that as well, where n is any integer value that we're able to multiply 2 pi by. So in this particular example, if n were 0, the second term drops out, so my solution is just pi sixth and 5 pi sixth. If n were 1, then be pi sixth plus just a 2 pi, which is what I've already discovered. And the other one was 17 6 pi. If n were 2, then it'd be pi sixth plus 4 pi. If n were 3, it'd be pi sixth plus 6 pi. And there you start to see the repetitive nature where a new solution is occurring every 2 pi, which is when a new cycle begins. And there's solutions to the positive side. There's also solutions to the negative side as well. So what are we going to do from here on forward? Well, we're going to learn how to solve trigonometric equations. Equations are different from identities. Identities are true for all values. Equations are true for some values. And how do we discover what those values are? That's what we're going to process and learn how to do. So let's practice together solving an equation that only has one trigonometric function in it. Process is the same. Let's isolate the variable term that we're trying to get by itself, we're trying to solve. So I want to isolate the sine x's on one side and all the other things on the other side. Do it a couple of different ways. Let's just go ahead and let's take 3 times the sine of x minus, I'm going to subtract 5x, 5 sine from both sides. Collect like terms. 3 sine x's minus 5 sine x's leaves me with 2 sine x's. And a negative 1 on the right side. We can add 2 to both sides. Negative 2 plus, it gives me a 1. Negative 2 sine x there, negative 2. And then divide both sides by a negative 2. So I was able to reduce it down and solve for the variable they're looking for. Sine of x equals negative 1/2. So within the period from 0 to 2 pi, where is the sign negative? Negative was if sign negatives were in the third and fourth quadrant. So what sign is negative but also has a value of 1/2? So we know that it's going to be 1 in the third quadrant. So we're going to have pi plus the value of 1/2 was pi 6. So pi plus pi 6, that gets it into the third quadrant, and that would equal 7/6 pi. And then there's another sign that's also in the second quadrant, and we determine that by finding 2 pi minus pi 6. And 2 pi minus pi 6 gives me 11/6 pi. So there's all the values within the period from 0 to 2 pi that have a sign of negative 1/2. Then from there, to find all the solutions, remember it repeats every cycle every 2 pi. So we're going to add to these plus a 2 times an n in pi. So we get every repeating value of both of these two values all the way. So there's an example of how we solve a trigonometric equation.